So it's great to have you in Holland for the first time, maybe at least
first
in climate.
professional time.
Yeah, for the first time in Holland. Thank you very much for letting us translate the book. It's a great book. I really enjoyed it. I read it in English. I read it in Dutch. So it's really well written, I would say. And thank you very much.
Thank you.
Just to introduce you further, I mean your CV is like 20 pages, so I'm going to give a summary because otherwise we are really running out of time. In 2012 you joined the New York University, yeah, that's right. And before that, it's really interesting, he worked for the Department of Energy under Obama, under the presidency of Obama. So you worked on the energy transition, I suppose, yeah? And before that, he worked as chief scientist for BP, the oil company. So you can now say, oh, yeah, so this guy is from the oil company, you know, now we understand where he's coming from. But this was actually not the case, because he was asked to join BP because they wanted to get rid of oil and gas. And they said, Steve, you have to come over to London to help us. How can we get rid of oil and gas? And maybe tonight you can also tell us a little bit about if that is possible at all, and in what terms, you know. And before that, because you had a very long career in academia, he was like for 30 years, he was professor of physics at Caltech, California Technology
Institute of Technology.
Yeah, Institute of Technology. It's a very prestigious university in California. So again, a warm applause and welcome.
Thank you. Let's see if we can get my first chart up. And meanwhile, let me just remark that it is great to be here in Holland, and particularly great to see so many people who are interested in a data-driven, factual, unbiased discussion of climate and energy issues. If I can get my first chart up, let's see. There we go. There's the title. I wanted to talk about that for a minute. The title, Unsettling Climate and Energy, is actually a triple entendre. One meaning is how I felt when I found out some of the things I'm going to tell you. A second is how you might feel when you learn those same things. And a third is the science is not quite as firm as you might think, nor is the issue of what we might do about the circumstances we're in. So climate and energy consume so much of the political and popular discussion these days. We know that the global temperature is going up. It's gone up about 1.3 degrees since 1900. We also know that the local and global climates are changing, and we would like to know how they have changed in the recent and distant pasts. We also know that carbon dioxide in the atmosphere is going up. It started at 280 parts per million a century and a half ago. It is currently 415 parts per million. Here is the data since 1960 or so. And we know that a lot of this is due to human activities, particularly the burning of fossil fuels. And so the question is, how will the climate change under natural and growing human influences? And you can see it's not going to be so simple, because in fact, even though human influences have increased steadily since 1900, the temperature hasn't done that. It goes up until 1940, it then goes down for a while, and then it goes up again. So things are not so simple as CO2 is heating the Earth. And then we'd like to know, how will those changes impact ecosystems and societies going forward? And maybe most importantly, How should society respond to this circumstance? The first three questions are science. The last question is much more complicated. Any response has got to strike a balance. On one side, we've got the certainties and uncertainties in the science and the hazards and risks of a changing climate. On the other side, we've got the world's growing demand for reliable, affordable, and clean energy. And in striking that balance, we've got to have a discussion of values and priorities, our tolerance for risk, how much do we care about equity between the generations or between the global north and the global south, and how effective and how costly might be any steps that we would take. I'd like to concentrate mostly this evening on the left side of this balance and talk about the science. We'll talk then a little bit about the right side and then even a little bit less about the middle. The science, unusually for a scientific field, is defined by assessment reports that are issued periodically by the UN, most importantly, the Intergovernmental Panel on Climate Change, or IPCC, and to some extent the US, UK, and other national governments issue their own reports. These reports are meant to survey, assess, and condense the scientific understanding at any given point when they're issued. The fifth assessment report from the UN was issued in 2014. The US government issued its own assessment in 2017 and 2018. One is expected later this year, the next one. And then the UN, over the last couple of years, has issued its sixth assessment report. You can see right away that these are multi-volume reports. They are enormous undertakings. Just the first volume of the sixth assessment runs at about 3,500 pages. It was written by 300 scientists over a couple of years. When you read these reports, and you've got to be a scientist to really read them in detail, they say important things and often surprising. But most decision makers, I'll show you a few on the next chart, have not read these reports. I know, because you need to be a scientist to really understand them. Nevertheless, in the popular discussion, the science is often invoked. There's President Biden in the US on the first day of his term said, "It's the policy of my administration to listen to the science." There's John Kerry, the ambassador for climate issues in this administration, who said at one point in the past, "The science is absolutely certain. It's something that we understand with absolute assurance of the veracity of that science." Now, many of you are probably not native English speakers, but I can tell you as a native English speaker, I can't understand what that sentence says. I just don't. We hear other people, John Kerry, Bernie Sanders, Mark Carney, former head of the World Bank, Bill Gates, Ernie Moniz, all talking about existential threat, climate crisis, climate emergency, climate disaster, even though you cannot find those words in the official reports. There's Secretary General Guterres, who is, in my mind, a particular offender in this regard. Code red for humanity. Billions of people are at immediate risk, he said 2 years ago. And then last November, we're on a highway to climate hell with our foot on the accelerator. Come on, all right? Does anybody really believe that? And then finally, and this one gets a bit more serious, U.S. Secretary of Defense, who is responsible for preparing the nation for threats from the outside, said, "We face all kinds of threats, but few of them are truly existential. The climate crisis is one of those. It's making the world more unsafe, and we need to act." Well, I think after Ukraine and now growing tensions with China, he probably has a better understanding of what an existential threat really means. So we've got this rhetoric, which is in some ways fluff, but nevertheless is, in my mind, pretty dishonest. I'm reminded of a situation from the movie The Princess Bride, where one of the characters, Vizzini, the guy with the bald head, keeps using the word inconceivable. And Inigo Montoya, the other guy, says, I don't think that word means what you think it means. And in this case, I don't think the science says what many people think it says. In particular, the climate is not broken, and we do not face certain disaster unless we take prompt action. So you might ask, how did the pretty good science in the assessment reports get turned into the science that dominates the popular discussion? And it's a long game of telephone. It starts with the observational data and the research literature. It goes into the assessment reports, and then on to the summaries for policymakers, which are not written by the scientists, but are written instead by the governments, and then the media, and then to decision makers and the public. And as you go through this long chain of information flow, there's much bad behavior along the way. For example, there's the confusion of weather with climate. Weather is what happens every day or every season. Climate is a 30-year average of weather. And so if you tell me there was a storm today or last week, I would say you're talking about weather. You're not talking about climate. Confusing climate change with a changing climate. As you will see, the climate is perfectly capable of changing all on its own. Yet when people talk about climate change, they confuse human-caused climate change with a changing climate. Highlighting of recent trends without historical context. I'll show you that in a bit. Implausible extreme emission scenarios termed business as usual. Minimization of uncertainties. Alarming predictions that never come true because they're a decade off and nobody ever remembers them. And then we've got activist reporters who are not experts in the media, who are on the climate beat. Their job is to produce alarming stories, and they do so without any real control on what they write. And then, as Marcel mentioned, there is suppression of legitimate divergence from the consensus. A couple of years ago, I decided to write a book, which has been mentioned, Unsettled, and we've just now got the Dutch translation, by the way, which is one of about a dozen translations that are either been done or underway in different languages, that is meant to get around this chain. Everything I wrote in the book is either right out of the official data or the research literature or out of the reports themselves, and is meant to give people a sense of what the science really says. So I'll take you through a couple of examples, also talking about misrepresentation, and one of them I want to use is Greenland and the rate at which Greenland has been losing ice. So I put a piece in the Wall Street Journal about a year and a half ago about this. I guess the pointer's not working. And on the basis of a NASA press release and an article in The Guardian. And the Guardian headline says, Greenland's ice sheet is melting 7 times faster in 2019 than it was in the 1990s. Wow, right? And the text says, the rate of ice loss has risen from 35 billion tons a year in the 90s to 254 billion tons a year in the past decade. Sure sounds like we're on the highway to climate hell, right? Well, I had the temerity to look up the official data and put it in a graph in my Wall Street Journal article. There it is. This is how much ice Greenland loses every year. And what you see is that from 1990 on the right side up to 2010 or 2015, yeah, it went up a lot. But what they didn't tell you was it went up by a comparable amount in the 1930s. And in 1930, human influences on the climate were 1/5 of what they are today, and then it went down again. And if you look over the last decade, it's actually been going down again. despite the fact that the globe is warming, CO2 is going up, all right? So this has clearly got not much to do with human influences, but has more to do with the currents and the winds in the North Atlantic. This is a clear example of misrepresentation by omitting historical context. And of course, the guys who generated this data wrote a letter into the journal after I published the article, and they said, Koonin's right, but we disagree with his interpretation. They never gave what they disagreed with. So at least I feel like I made my point. Heat waves. We often hear heat waves are increasing in the US. Here's the official government graph of the heat waves since 1890, I guess, in the continental US, CONUS. And you can see, yeah, it's going up a bit from 2000 to 2020, but in fact, it was more in the 1930s and was just about as much in 1900, even though human influences were much smaller then. If you look at the EPA graphs, there's another set of graphs that start in 1960 and only show you that data. All right? Completely dishonest. I feel obligated, I should say a little bit about the recent heat that we've seen, the heat waves in US and Europe. This is a graph of the satellite-derived temperature anomaly in the lower atmosphere. And what you can see, the blue lines are the month-by-month values, and the red line is the running annual average, or 13-month average. And what you see is a lot of fluctuation from month to month, but the red line goes up more or less steadily. The fluctuations, the peaks that we see, there's a big one there in 1998 and several others in the last 20 years. These are due to El Nino events, which are natural fluctuations of the system. And we see one just in the last couple months. This graph ends in August. Those can't be human influences, cannot be carbon dioxide, which acts in a continuous and steady way. And so what we saw last couple months is a fluctuation built upon a smoothly rising trend, right there. Causes we don't know. Think we can rule out greenhouse gases. El Nino, I mentioned, plays a role. Water vapor in the upper atmosphere plays a role. You may not be aware that in January 22, there was an enormous underwater volcano eruption, which increased the water vapor in the upper atmosphere by 10%. Water vapor is a powerful greenhouse gas and may in fact have contributed to the warming of the planet. There is the data just to show you that we can see the water vapor setting in the dark green blob at the end of the graph and then persisting for a couple of years. We've also made pretty good progress in cleaning up the aerosols in the lower atmosphere from ships and from coal plants. Those aerosols exert a cooling influence on the planet. If we're taking them away, it will make the planet warmer. So this is still up in the air. Urban heat islands are another cause. But just to say that just because we've seen some heat waves around the planet the last 2 years does not mean it's greenhouse gases. Okay, what's surprising is even though the temperature is going up, when you look at the official UN report, here it is. This is Working Group 1, Table 12.12. What you'll find is for most extreme weather phenomena, there is no detectable trend. What you can see listed are many different phenomena associated with heat and cold, wet and dry, wind, snow and ice, and so on. And the color coding indicates that there is a medium or high confidence of a trend either decreasing or increasing. And what's interesting is that for the trends associated with heat, extreme heat, cold spells, and so on, there is a finding of a trend, but for most of the rest, there's no detectable trend at all. Here are some of the words that go along with it. I'm not going to read through it in detail, but we can make the charts available to people on the web. I'll just read the first one or two. Low confidence in most reported long-term trends in hurricanes, either in frequency or intensity. Low confidence in changes in extratropical storms. No confidence in changes in tornadoes, hail, lightning, and so on. You can go through all of these, and it's kind of surprising, given the way the media keeps talking about extreme weather, that you find this in the official UN report. Here's some of the data. Hurricanes. This is 50 years worth of hurricane data. Tropical storms on top and hurricanes on the bottom, and it's hard to find any trend at all. This is another measure of hurricane activity, again for the same 50 years, and yeah, it goes up and down, but if you look for long-term trends, it's hard to find anything. And in fact, the official reports say that. Low confidence in any trends, et cetera, et cetera. How come we don't hear that in the news? Well, you can make up your own reasons why, probably right. Let me turn to sea level for a little bit. Sea level, a very important consideration in this country, of course, it's been rising for 20,000 years. This shows global sea level over the last 20,000 years, and you can see it's gone up until about 6,000 years ago, 8,000 years ago. It's gone up by 120 meters. That's 400 feet. Wow, all right. Of course, since about 8,000 years ago, it's been going up more slowly. This is, of course, because the glaciers melted and put a lot of water back into the oceans. So the real question is not whether sea level is rising. It's whether it's rising more rapidly due to human influences, let's say since about 1900. And the discussion hinges on 1/10 of a millimeter per year differences. We'd like to know to what extent is that rise human-caused and what's going to happen in the next few centuries. Well, the UN report, AR6, does a wonderful job of obscuring the issue. What you find when you look at it, here is figure 8 from the Summary for Policymakers, is you see trajectories of the sea level itself under different emission scenarios, and they're all kind of featureless curves. And what they say, we'll look at the text in a minute, but here is what the rate of sea level looks like from one of the papers that they cite. And what you see, it goes up and down. It's not rising smoothly at all. But look at what they said in the IPCC report. Global mean sea level increased by 0.2 meters between 1901 and 2018. Okay, the average rate of sea level rise was 1.3 millimeters per year between 1901 and 1971. So they give you the average over that period, increasing to 1.9 between 71 and 06, and then further increasing to 3.7. They completely ignored comparable variability earlier in the 20th century. If one of my students had done that, I would have failed them. Right? It's complete misrepresentation. And in fact, a previous report said that there were comparably high rates in the from 1920 to 1950. So the reports are getting more and more in the direction of trying to persuade you and less about representing actual data. Well, that's what happened in the past. Let's talk a little bit about projections of future climates. And these rely on large computer models. And let's take a minute to explain how they work. So you cover the globe, the surface, in squares, these days of about 100 kilometers on a side. And then you build a stack of voxels, boxes, let's say 20 layers up into the atmosphere and 10 layers down into the ocean. When you do that, you wind up with about 100 million voxels. And what the computer program does is to use the basic laws of physics, conservation of matter, energy, flow of radiation, and so on, to track the air, the light, the water vapor through these voxels 10 minutes at a time. And you have to do that for a couple centuries in order to describe the climate. So we wind up with 100 million voxels over about 100 million time steps, and that needs to be done with an accuracy of 1 part in 1,000, because that's the scale of human influences on the climate system. The world has many different models, about 50 of them, some done by the US, some done by the Europeans, Russians, Chinese, other people in Asia, and so on. The models don't agree with each other, and they don't agree with the data either by as much as the change we're trying to describe. One of the problems that make them so variable is that the grids are 100 kilometers and aside, but the phenomena in the weather that you're trying to describe happen on much smaller scales. A thunderhead, for example, might be 5 kilometers across. And so you can't follow all that detail in every voxel. You have to make assumptions. The temperature in the voxel is so much, humidity, winds, then we might have so many clouds. Different people make different assumptions, and so they get different answers. Particularly vexing in the models generally are clouds. They happen on these smaller scales, and particularly the feedback from the clouds. As the globe gets warmer, there will be more water vapor in the atmosphere. That will make more clouds, which influences how much sunlight gets absorbed, but it also influences how the heat radiation comes out of the planet. And those intertwined processes are pretty difficult to describe. The models also have a hard time describing the variation of the global climate on scales of a few decades. This is a graph of what's called the Atlantic multi-decadal oscillation. And what you can see is that it's got something to do with the currents and the winds in the North Atlantic. It varies on a 60-year timescale. The models do not have this, nor do they get the right frequency or the right intensity or the right timing. Okay. And when you look at the history of the models, let's say between AR5 and AR6, they haven't improved much over 15 years, even though they have become more sophisticated and the computers have become more powerful. And when you look not at global quantities, but at regional projections, let's say, is it going to get wetter or drier here in Northern Europe, they're even more uncertain than at the global level. Here are some examples of how they're deficient. This is a graph showing some 40 models, and what's plotted is how sensitive the model is to increasing carbon dioxide. And what you can see is about a third of those models, the ones in yellow, have been deemed too sensitive to be of much use by the IPCC. That's pretty disturbing, unsettling, if you like, because, in fact, the world's best modelers, trying as hard as they can, get it very wrong about a third of the time. Here's some detail about how the modelers do or do not reproduce historical trends. If you look at the left panel, that's the global temperature since 1900, shown in black, and the different traces, the spaghetti, are the different model reproductions. And you can see that they differ by more than the warming we're trying to describe. In no field of science is this considered a success. And the modelers know that. Here are some words from the climate modelers themselves, Tim Palmer and Bjorn Stevens, two big shots in the consensus modeling effort, writing in PNAS. For many key applications that require regional climate output or for assessing large-scale changes, we believe that the current generation of models is not fit for purpose. And here is Bjorn, who's the director of the Max Planck Institute for Climate Science, saying, "It's difficult, in many cases impossible, to scientifically advise societal efforts to adapt in the face of unavoidable warming. It's impossible to assess the extent to which a given degree of warming poses an existential threat. Even more frank was Tim Palmer, who's a professor at Oxford, writing in a private email, "Our understanding of climate change, especially at the regional scale, is rather poor. How can a country adapt if it doesn't even know the sign of precipitation change with any confidence, as the IPCC figures show?" And what he says is that the same policymakers, if we're let out of our ivory towers to express that fact, the same policy and decision makers start to feel uncomfortable. They'd rather we didn't say such things in public. They claim it undermines the public's faith in the need to take action. All right. I'm really disappointed. I mean, Palmer is a fine scientist, but to have this kind of two-faced attitude, public versus what he'll say in private, particularly for a matter as important as this, kind of disappointing. So let's go back to the models and let's look at sea level. What might the sea level do in the future? I live in Manhattan, used to be New Amsterdam, and since 1850, there's been a tide gauge at the tip of Manhattan, the southern tip, called the Battery, and it's measured the sea level. And what's shown here is the data, how much, if you average over 30-year periods, how fast did the sea level go up? And what you see, first of all, the average is about 3 millimeters a year, which is a foot a century, easily manageable. But what's also surprising is that there are ups and downs, presumably having to do with currents and winds in the North Atlantic. And even more surprising is that 1 millimeter of this number is due to the fact that the land is sinking rather than the ocean rising. Anyway, last year, NOAA, the U.S. National Oceanic and Atmospheric Administration, issued a report that said this graph is going to do that by 2050. It's locked in, they said, independent of emissions, independent of the model, and so on. Now, who am I to challenge NOAA, right? But we'll know soon enough whether this is going to be right or not. More words about how bad the models are. I'm not going to go through that. Well, what might happen in the future as the globe warms, besides sea level going up? Hard to say, but we can draw some information by what happened in the past, and I want to take you through that a little bit. The globe has warmed 1.3 degrees since 1900. About the same amount of warming is projected to the end of this century, another 1.3 degrees under plausible emissions scenarios. And as I said, it's kind of hard to understand what the impacts might be, but in fact, we can look at what happened in the past. And when you do, by almost any measure, humanity has prospered as never before, despite the fact that the globe warmed, or maybe because it warmed. When you look at the population from 1900, it's gone up by a factor of 5 to the current 8 billion. Life expectancy went from 32 years in 1900 globally up to 73 years today. GDP per capita in constant dollars went up by a factor of 7. You can go through many other metrics, and the last one that's relevant here is that the death rate from extreme weather has gone down by a factor of 50 since 1900, as we've gotten better at predicting storms and also building a more resilient infrastructure. I'll take you through another IPCC misrepresentation of this kind of thing now for temperature-related deaths. There's a journal paper in The Lancet, and what they did was to look at 20 years of deaths globally, and they found 5 million deaths per year associated with non-optimal temperatures. That accounted for 9.5% of all deaths, and equated to 74 temperature-related excess deaths per 100,000. That's just about what the rate of death from infectious diseases were before COVID. Most of the excess deaths were linked to cold temperatures. 9 times as many, whereas fewer were linked to hot temperatures. About 1/10 were hot temperatures. The global daily mean temperature increased by 0.26 degrees per decade during this 20 years, paralleled with a large decrease in cold-related deaths and a moderate increase in heat-related deaths. Okay? So as the globe warmed, fewer cold spells, more people surviving, and more warm spells, but a few more people died. Here's what the IPCC summary for policymakers said about all of this, and it's the only thing they said about it. In all regions, increases in extreme heat events have resulted in human mortality and morbidity with very high confidence. They forgot to tell you that the cold-related deaths went down by a lot more, so that actually fewer people die from extreme temperatures over the last 20 years. This is a completely factual statement. You can't say it's wrong, but it's factually incomplete. And so it is aimed at persuading you rather than informing you. Again, one of my students did this out the door. Let's look at a little more data. Agriculture, important in this country. This is agriculture since 1961, and it is cereal production, wheat, rice, and so on. And you can see that the lower trace, the land use for cereal production, hasn't changed much at all. The population, the next train, has gone up by 150%, but the yields and the production have gone up enormously. And what the IPCC says, never missing a chance to say something bad about changing climate, it could have been better if the climate had not warmed. Who knows, right? How can you prove that or not? But the point is, we're doing just fine so far. Marcel showed you this graph already. What I would point out, which he didn't say, is that the vertical scale is in tenths of a percent of GDP. In other words, extreme weather losses accounted for about 0.2 or 0.3% of global GDP, slightly declining. Global GDP grows by 3% a year or something, so this is a minor and decreasing drag on the global economy. If you say, well, that's all denier talk, this is a graph from the Biden White House that got issued in March. And what it shows is that the percent impact on the US GDP as a function of temperature rise. Apologies that it's in Fahrenheit, but the vertical line is where we are today, and about 4.5 is where we might be at the end of the century. And they looked at 12 different peer-reviewed studies, which are the 12 curves you see over there, and the black one is the average. And what's remarkable about this is that the vertical scale is measured in percent again, and you're looking at a couple tenths of a percent at most. All right? Now you might say, well, it's all uncertain, it's all models and so on, but it's not 10%. So it's not a disaster at all for the US. There are similar graphs for the globe as a whole, a few percent hit on GDP for a few degrees of warming. This is in the official data, the official literature, the White House. So I don't understand how the president keeps talking about existential threat. I'm not going to go through tipping points. The IPCC even says that. This is from the 5th working group, text verbatim. For most economic sectors, the impact of climate change will be small relative to the impacts of other drivers. High agreement, medium evidence. Changes in population, income, policies, etc., will have a much greater effect. As I said, most of what I say is not my words, but it's what's in the reports. Nobody ever reads it. This is the last chapter in the second most recent report. All right, let me spend a little bit of time now talking about the other side of the balance. Talked about the science, I want to talk about energy demand. We start with population. This is the global population projected up until the end of the century, and you can see great growth in Asia and in Africa, increasing from 8 billion people today up to 10 billion people. Those people are going to need energy, not because so much there are more of them, although that's a factor, but because they're going to develop and become economically more prosperous. This graph shows how much each person uses in energy per year on the vertical axis, and what is the GDP per capita on the horizontal axis, and shown for different countries. And in the upper right, you've got a couple of prosperous countries that use a lot of energy per capita. The US is up there. Canada is up there. In the middle are a lot of European countries that are pretty prosperous, also about half the energy per capita. And down at the bottom, a lot of countries in the developing world whose energy use increases steadily as they become richer, almost universally also. And what is sobering is that there are only about 1.5 billion people in the OECD countries in the upper right part of this graph. There are 6.5 billion people roughly down in the bottom left. And you can be sure as they improve their economies, as we should hope that they will, they're going to need more energy. So about half of the world's people are down in that part of the... We tend to, at least I and many people in the US, tend to live in a kind of developed world bubble and don't have appreciation for what the rest of the world is like. Energy poverty is astounding. People cooking with what's called traditional biomass, wood, dung, indoor air pollution kills about 3 million people a year. People studying by candlelight, and a little bit of energy makes an enormous difference here. The US per capita energy use is 30 times that of Nigeria, just to take an example. And there are 3 billion people in the world who use less electricity every year than the average US refrigerator. Think about that a minute. Nobody wants to live like that if they don't have to. We should hope that these folks develop. So where's the world been getting its energy so far? This shows, 40 years worth of energy sources. And you can see that the lower three panels, oil, coal, and gas, still provide about 80% of the world's energy up until last year. The renewables, of which there's so much fervor, are up there in the upper right. You can see small, growing perhaps, but still small. The world has spent $4 trillion over the last decade to try to promote renewables. Not much of a dent. So you can take the population and the development and project what energy is going to be and where it's going to come from. Energy demand is going to go up by 50% over the next 30 years. And most of it, unless we make radical changes in policies, is going to continue to come from fossil fuels. Although renewables, wind, solar, hydro, will grow to some extent as well. The world needs energy. If you look at emissions, then, projected going forward, emissions from the developed world, the dark blue, will be declining slightly, whereas emissions from the developing world will be growing as they secure the energy they need. It's immoral to deny the developing world the energy that they need. Anthony Downs was an economist working in the 60s and 70s. He wrote a wonderful paper called Up and Down with Ecology. And what he said is the elite's environmental deterioration, worrying about deterioration of the climate, is often the common man's improved standard of living. Right? And so when people say the science compels us to make large and rapid reductions, the developing world says, what do you mean us? So here is Indian Prime Minister Modi a while ago, and he said the same thing at the G20 last month. The colonial mindset hasn't gone. We're seeing from developed nations that the path that made them developed is being closed for developing nations. And then the Nigerian ex-president, he was deposed in a coup a month or so ago, said Africa is being punished by decisions of Western countries not to finance foreign fossil fuel projects. We've got resources and assets that need to be exploited to improve our economy. So whenever I hear somebody says, we've got to reduce global emissions, I think the first question is, what are you going to tell these 6.5 billion people? And I've not heard a satisfactory answer yet. You should ask that to your leaders here in the EU. We've also, this climate alarm has really robbed youth of their optimism. People don't want to have children. They don't want to get married. They think the world is going to end. And unfortunately, most of that is here in the West. It's not in Asia. Serious implications for geopolitics. I can't resist. I always wanted to show a picture of Miley Cyrus in one of my talks. She said a while ago, we're getting handed a piece of shit planet, and I'm not going to bring a child into this world. Come on. Really? All right. Last section, are large and rapid reductions possible? This is a graph for the U.S. It shows how the U.S. got its energy since 1950. Different sources, you can see that they grow, but they all pile on top of one another. You don't see much of a decrease in one source as another one grows. But more importantly, what you take away is that it takes decades to change an energy system. There are large investments that last a long time. Things have to be interoperable. Many people have many different interests in the energy system, so there's all kinds of tension about what happens. It takes decades. What I think we're seeing in the last year or two is best characterized by this cartoon. I assume you know about Roadrunner. And this is Wile E. Coyote. And he has been run off the cliff and has suddenly realized that there are a number of fundamental factors that are going to spell a bad end for him. And as the world has been rushing to an all-renewable, all-electric world, heat pumps instead of gas furnaces, electric cars instead of petrol or diesel, they've suddenly realized, oh my gosh, it's not so simple. And experts who have studied this, even studied this 20 years ago, knew about some of the problems we're encountering, and I'll list them in a moment. And what's interesting to me is how come it's only just becoming evident to the public and decision makers now? Why was that suppressed? So let's just go through a list real quickly for the last little bit. The downsides of trying to do this too rapidly. To borrow a title from a current movie, energy touches everything, everywhere, all the time. It's infused in all aspects of what we do. Energy systems evolve best over decades. As one of my colleagues once said, best to change them by orthodontia, not by tooth extraction. And so you tinker with these systems at your peril. Attempts to accelerate an energy transition are going to be extraordinarily disruptive. We're already seeing that already. The cost and reliability of the grid and other energy services, changes in domestic employment and flows of funds, petrol taxes will disappear as electric vehicles become more common. What do we do to make up that money? Domestic manufacturing costs are going to increase, and so you see industries fleeing, for example, in Germany, when energy becomes more expensive. We're putting in immature technologies. The first generation of wind turbines is already falling apart. We need new supply chains for critical minerals. I'm not going to go through that, but it's a concern. And maybe more importantly, the opportunity costs. To decarbonize over the next 30 years by 2050 is estimated to take 5 to 7% of the GDP. whether it's in the US or globally. That's a lot of money. You could do a lot of other more impactful things with that money than decarbonize, particularly since Holland's emissions are only 0.5% of the globe. And if you went to zero today, nobody would notice in the climate. So we are starting to see pushback on the regulations, enhancing political divisions and strife. Some people think we've reached peak green in Europe. Political changes in Germany due to the boiler regulations, France, here in the Netherlands, in the UK. The mandates in the US are just beginning to affect everyday consumers. I think the US is about 2 years behind. Email came across my desk a couple days ago. I thought I'd just list the headlines. Following Sunak's lead, the German government is suspending tightening of efficiency rules. Macron rules out a ban on gas boilers and attacks climate alarmism. You can go down the list. I think people are starting to realize just how difficult this is going to be to do quickly and are starting to say, tell me again why we're doing this? All right. What I conclude from all of this is adaptation is going to be the dominant response. Adaptation is agnostic. It doesn't matter why the climate's changing, whether it's natural or human caused. It's proportional. You adapt more if the change is greater and adapt less if it isn't. It's local. And so it's politically palatable. You're spending money on changes locally as opposed to something that might happen several generations later, halfway around the world. It's autonomous. It's what people do. It's what humans do. And it's effective. This country is sort of the poster child for adaptation, and more power to you. Okay, let me close with two thoughts. On the science side, we must not Gruberize climate science. And what do I mean by that? There's Jonathan Gruber. He's an economist at MIT. And in the second Obama administration, he was one of the principal architects of the Healthcare Act called Obamacare, which changed healthcare in the US for the better in many ways. After it was all over at a conference, he said the following: the lack of transparency was a huge political advantage. It was really, really critical to getting the Affordable Care Act passed. At least one key provision was a very clever basic exploitation of the lack of economic understanding of the American voter. And I can tell you, for an academic, somebody who's responsible for teaching, to say something like that is despicable. So when the science gets misrepresented, as the IPCC and the politicians have, to persuade rather than to inform, it takes away the right of the public to strike that balance and make a fully informed choice. It distracts from more urgent needs, the 5 to 7% of GDP, and it tarnishes the input of science to other important policy matters like COVID, for example. And as we've said, depresses young people, and that's why I wrote the book. All right, I've been telling you everything that's bad. Let me tell you what I think we should do. Last chart. We got to cancel the climate crisis. Anybody who uses words like that should be shouted down. Nevertheless, we should acknowledge the task and challenge of ultimately reducing human influences. We need to do better representations of the science and technologies to non-experts. The Clintel Red Team review that Marcel mentioned, I think is a great way of getting started on that. Of course, it has no official sanction at all. It was an entirely independent effort and should, but won't embarrass the people who write the IPCC reports. We need better energy and climate literacy for people. I teach energy and climate, two separate courses, to 25-year-old students at NYU, and after they're done reading the official reports, their eyes are opened up. We need to work more on the climate science, better observations, really important. We must not constrain the developing world's energy supply. I think we need a greater focus on adaptation. And then we, in the developed world, need to be working on developing and demonstrating low emissions technologies, making them about as expensive or no more as expensive than fossil fuel technologies. Fission, grid storage, batteries, non-carbon chemical fuels, you can go on and on. In this regard, Bill Gates has got it right, that technology development is in fact the way in which this is going to be addressed, if at all. And then finally, on the policy side, graceful decarbonization pathways that worry about technology, economics, behavior regulation, and so on. Right now, we're just throwing stuff at the wall. Let's do a lot of wind, let's do a lot of solar, let's get rid of internal combustion. And a lot of it is not going to stick, unfortunately. So let's get mature and thoughtful about these things. Thank you for your attention. And I gather we'll at some point have the opportunity to do questions. Marcel knows what's supposed to happen. I think we're supposed to take a break right now. I'm happy to sign some books in the back, and here comes Marcel, who's going to tell us what the real story is. All right? Thank you.
Thank you. Thank you so much, Stephen. Wonderful presentation. I've seen many of yours, so many familiar slides, but still wonderful round story. So yes, indeed, on your chair you had these small papers, and what we will do to make things more fluent, because we all know that Q&A with a microphone going through the room, it takes ages. So what we will do is, if you have a question, you can write it down, leave it at the table where you can buy the books, and where Steve also will sign his book. There are also some English copies, by the way, of Unsettled, and lots of Dutch, of course. And so then, let's say we take a half an hour break. So at 9:40, we are back here, and I will then moderate the questions for you and to speed it up a little bit. Yes? So enjoy your break and see you back. Well, thank you so much for joining and for staying. We didn't know what to expect. We thought maybe because of the time, people need to take a train, etc. So it's very good to see so much involvement and that you're still here.
And we better not disappoint.
Yes.
Okay. So
yes.
We got to do a good job.
Yeah.
All right.
And there were incredible amount of questions, and I have to admit, sometimes I couldn't read them. It's because I'm getting older and I need reading glasses, and I didn't bring them. So it's not personal. It's not personal. Okay. What we will do is we have a few topics, yeah, and we start with more technical questions, like scientific questions, and then we go to the more communication and the motive, what we call the motive questions. Yeah? Why is this happening? What Steve explained in his talk. Yeah? So this is a nice one to start with. Is it indisputable that greenhouse gases cause higher temperatures? Some scientists still deny that as well.
I think if you go back to the basic molecular physics of what we understand from laboratory work about the way in which water vapor and carbon dioxide interact with the heat radiation coming from the planet, I think it is indisputable that they exert a warming influence on the planet. That's counteracted by a cooling influence from the aerosols, the particulates that get emitted from deserts, from forest fires, from burning dirty coal. And that takes off about 1/3 of the warming influence of the greenhouse gases. But I think, at one level, you can say that part of it, the warming influence, is really just physics. So I think that's pretty indisputable.
Yeah. And a related question, I think I have the wrong, selection. But a related question is that about saturation. Of course, you have a lot of contact with Will Hepper. He also visited us.
Yep.
And how do you see the saturation issue? So the idea that more CO2 has a decreasing
lesser effect in the inch increment. So the precise mathematics. You'll excuse me if I descend to mathematics for a minute. The warming goes as the logarithm of the concentration of CO2 divided by the base concentration, which is 280. So right now we're 415 over 280 is some number. If it were to double, so we went to 560 instead of the current 415, then the log is 0.7, the log of 2, rather than 1. So it's a 30% effect on the influence as if we got to doubling CO2. Something to take into account, but not so much that it would significantly decrease the warming effect. There are other greenhouse gases. Methane is important. It's about 30% of the CO2, and it's not saturated as much, and so it actually goes as the square root of the concentration rather than the log. So these are complicated, but the kind of effects that Will and others have talked about are real, but not particularly strongly operating at the current levels of concentration.
Yeah. Okay. This is more a policy question. Which renewables do you think have the potential to fulfill potential of the energy mix in the future?
So let me spend a minute going through my take on renewable electricity. And currently the fashion is wind. You see a lot of wind turbines as you drive around here, probably more offshore, and solar. This is not a particularly sunny country, so I'm not sure solar makes a lot of sense. But let's talk about the wind. The wind has some advantages. No fuel required, no greenhouse gas emissions in manufacturing, in operation, but some in manufacture. But the biggest problem is the intermittency. The turbines will not spin unless the wind is blowing. The wind does not blow all the time. And so if you want reliable electricity, which we do in the States, the standard for electricity availability is 99.99% of the time, then you worry when the wind is not blowing and you need some kind of backup system. And you might think, okay, for a few hours I can build a big enough battery or do something else to provide the reliability. But unfortunately, there are long periods, not very common, but they happen, when the wind does not blow. The Germans call them Dunkelflauten. I'm not a German speaker, so apologize for them. But basically, you see 10, 12 days at a time when it's calm. That phenomenon is also present in Texas, where you see a month in the summer where there's not much wind, similarly in California. And so you need a backup system that will run for 2 weeks at a time, which is as capable then as the original wind system. And so you wind up running two parallel systems to guarantee the reliability. And so you might ask, well, if I'm running the backup system, why am I running the wind to begin with? Good question.
Back to the greenhouse effect. Here's an extreme question. How much greenhouse gases is allowed before life on Earth isn't possible anymore? Do you have any idea about that? Or is that a question for Will Hepper?
Yeah, no, I think you can just go back in the geological record. You go back 100 million years and the CO2 concentration was 10 times what it is now. Mm-hmm. And there was certainly, life was possible, was a very different kind of life. We had dinosaurs and lots of things growing, as you might imagine. But look, even if we continue to emit, it's going to be a slow creeping up. And I don't think that will be beyond our capabilities to adapt.
Yeah. A more realistic question that I would pose is, okay, we both agree that there is currently no climate crisis, but what could change your opinion about that? I mean, what in the climate system, what changes in the climate system would convince you that there is a climate emergency?
I think a much longer and stronger presence of extreme events. So really rapid warming, much more rapid over the next decade or two, that the tropical cyclones, the hurricanes and typhoons, for a decade become much stronger. Things of that sort. Okay. Then, and you might have a crisis even if it's not due to CO2. The weather or the climate has natural cycles, as I showed, of its own. So firmly attributing it to humans is quite a separate step beyond just detecting a trend.
Yeah. Okay. Okay, then we go to the more like the motive questions, and that is, for example, what is driving this agenda for change? And why are scientists willing to cooperate with political agendas?
Yeah, it's, boy.
Sorry.
As I wrote in the book, I think it's an alignment of interests rather than a conspiracy. I'll start with the media. If it bleeds, it leads. It's wonderful to have a climate story every week. You can calculate how often 100-year events happen around the globe. And there's one every couple weeks, somewhere of some kind. And so whether it's floods in Libya or fires in Maui, it's got something to do with the weather, and it's easy to blame it on the climate, right? Why not? For the politicians, I like to quote H.L. Mencken, who was a reporter in the 1910, 1920 in the US. And he wrote something like, the purpose of practical politics is to keep the electorate alarmed by mostly imaginary hobgoblins so that they can be clamoring to be led to safety. So that's one. In the US, both sides do it. Climate, immigration, and so on. So politics is best done by crisis if you're a politician. The other thing about the climate that I think the politicians exploit is that it's a great excuse for other failures. So take Libya, we just had, right? There were deluges like that in the past, some actually stronger. The dams that failed, 2 of them, it was known for a decade or more that those dams were in poor condition. There were reports, we just discussed this in my class on Monday night. There were reports, and of course nobody did anything about it. You can go back to Katrina and the lake that failed, also reports. Maui, a report a decade ago that says this is going to be a problem. Nobody does anything. And so the politicians can say climate and wash their hands of it. For the scientists, in private, the scientists are much more, there are many more caveats in what they say. In public, they don't dare cross the politicians, they'll lose their funding, and they may get canceled by their colleagues. We've seen that happen with other people. So there's a lot of peer pressure not to speak out much. And I find that very disheartening. If the public can't get accurate, unbiased information about the climate, we have no hope of making the right decisions, whatever they might be. So.
What about IPCC? Did it go wrong from the start? I mean, you and I both agree that IPCC currently is off track. It's getting more alarmist. It's getting, the cherry picking is getting worse. You showed examples. I showed an example.
Yep.
But do you think it went wrong from the start? For example, in the break, somebody came to me and said, what about the definition? The definition is already wrong. You know, the definition by the IPCC was like, or in the Rio agreement in '92, it was like climate change is only the change due to greenhouse gases.
Human greenhouse gases.
Yes, exactly, human green. So climate change is defined in a very narrow way.
Right.
Did it go wrong there already? So did it go wrong in the start, or was it like a self-fulfilling process where they selected those scientists that...
There is that. If you read the early IPCC reports, up to about the third one, they're actually really quite good. And I think part of that was...
Apart from the hockey stick?
Maybe. Yeah. That was that 4? Or
it's 3?
Okay. You had the A team of scientists, because it was a new exercise, everybody wanted to be involved. And you didn't have so much the heavy hand of the government. As it got later, yes, the government selects the scientists, writes the summaries, and they kind of back themselves into a corner, right? By saying successively, we're more and more certain it's humans. You can't backtrack then, even if new information comes out. So I think it's all those things.
Yeah.
I know distinguished climate scientists who are not involved currently who will say we now have the B team writing these reports.
Yeah. And then what about the red team, blue team? Because I heard from Will Hepper, and you were also involved in this. I mean, you became interested when you had to lead this dialogue for the American Physical Society back in 2014 or something, where you had 3 skeptics and 3 mainstream scientists, and you were like the moderator. And so this was the first time that you were like, oh my gosh, there are actually 2 sides, and they both are valid, or more or less. But tell us what is a red team, blue team exercise, and why did it fail so far?
In major technical issues, and the ones that stick in my mind are mostly big, adventurous construction projects, whether it was a spacecraft, which I saw up close when I was at Caltech, JPL, that builds all the big interplanetary spacecraft, or the giant laser at Livermore that I helped review 30 years ago before. It's not that bad. Okay.
He has been so quiet so far. This is the dog of our full-time volunteer, ladies and gentlemen. So it's
I'm
a great honor to have
so it's
her
just
here.
fine. Yeah, right, that's great. You know, when you commit to building an adventurous project like that, or making a major decision, you bring in a second set of qualified experts who are not involved in designing or building, and you ask them, what's wrong with this picture? Tear it down, find the flaws. And sometimes they do, and it makes you change the spacecraft or change the design. And it's very useful, and a good engineering team or a good science team will want that kind of scrub. We are making major societal decisions on the basis of these scientific reports. And they do not undergo the same kind of scrub that even a good peer-reviewed publication would undergo. That's manifest because, as Clintel wrote in their Red Team report, as I did a bit in the book, you could find glaring misrepresentations or inconsistencies in the document itself. And there are enough of them all in the same direction that you know it's not accidental. And so I, together with Will, while in the Trump administration, Will was inside the White House, I was outside, we tried to get that administration to run a red team, blue team review. And in the end, they decided, I think for political reasons, not to do it. But I would be hopeful that the next time around, something like that gets done.
Yeah, okay. I heard that Trump personally was really in favor of it, but that his advisors, because of the re-election that he ultimately didn't get, of course.
Yeah, I was not there in the White House, so I don't know what happened.
Yeah. Okay, back to a scientific question, because you said little about the sun. So there is a question about the sun. How do you look at the solar influence? You're probably aware of this new paper with Willie Soon. I'm also a co-author, by the way. No. So, so there is a lot of discussion. How do you see it?
So people should understand that human influences are small. They're 1%. But the climate is very sensitive. And so a 1% influence would lead to, you would think about a 1% change in the temperature. And if you measure the temperature in physicists' way, namely absolute temperature, it's about 300 degrees. 1% is 3 degrees, which is about what we're talking about, all right? So small influences, but sensitive. The fact that it is sensitive means also that other influences, if they change a little bit, can have a comparable effect. So if you change the solar constant, the intensity of the sun, by 1%, you'll change the temperature enough to make a difference and worry about. Similarly, it's not, of course, as you well know, just not the sunlight intensity itself, but there are particles coming out of the sun, magnetic fields, and so on. The IPCC line is that many people have looked for those influences, 11-year, 22-year cycles in climate variables. They say have not been found. I think it's real interesting that you guys and others have found such cycles, and I think it's now up to the rest of the community to respond. I mean, that's how science works, all right? So I would say interesting. Let's hear what the other side says in response.
Yeah, okay. And related to that, because you said, well, in your opinion, the system could be quite sensitive. Mm-hmm. So it could be possible that there are tipping points in the climate system. How do you view those? Because you can make easily headlines with a potential tipping point, like a slowdown of the Atlantic currents,
outgassing of the permafrost.
Yes, methane, from
deforestation in the Amazon, and so on. Let's see. First of all, we see no indication of those in the models, but the models probably don't have enough degrees of freedom. It's been very rare to see anything like that in the past. There was the Younger Dryas, which you may know about, which was an inflow of fresh water about 11,000 years ago to the North Atlantic and cooled Northern Europe a little bit from what it had been. They happen. They are geologically rare. But again, you might ask, what are the impacts? And I go back to the economic impact estimates. And there was a paper which I skipped over. They considered 8 different tipping points: AMOC, deforestation, Greenland melting. It's another 1 or 2% on the economic hit, so not much. We're wonderfully adaptive. So, no, something to be watched for, but not something to make radical changes in society for. Because we don't know how close we are or far from them. You don't know whether we're helping or hurting by adding greenhouse gases. So,
yeah. Here is a nice question about how your book has been received by the public, but also by the university where you teach currently.
Let me do the second one first. The book was published at the end of April, and along about March, I sent the manuscript to the president and provost of New York University. They're both friends because former academic administrators kind of have a network, a brotherhood. And the president was a scientist at the time. At the time, the president was a scientist. Andy Hamilton was a chemist. And he read it, the provost read it. She was a humanist, the provost. And they both came back and said, this is real interesting. I don't know whether to believe it or not, but we're not going to stand in your right to publish it. And so it's been all good. My department chair is a big fan, actually, so that's positive. In terms of the general reception of the book, gotten many spontaneous emails from engineers, scientists, and other disciplines who say thanks for writing, not only for the content, but kind of the framework that you've given me to think about these issues. In the climate science community, I had one prominent climate earth scientist from a very prominent university whom I've known for a long time, tell me, when I asked him what he thought, he said, Steve, I think you got it mostly right. I would quibble with figure 60-something, which is 1 out of 70 figures in the text. On the other hand, the public reaction by some very prominent defenders of the faith was very disappointing. Let me just say that. There's, for example, a piece that was written in Scientific American by a dozen climate scientists, including Michael Mann, Naomi Oreskes, and so on. That's 1,000 words, and it was disappointing in two ways. One, it was filled with ad hominem attacks, a crank, a shill, and so on. And then the three scientific points they tried to make were not about things I said, but about things a review of the book had said. And what's even more disappointing or amusing, I got to debate one of the authors, co-authors of that, Andy Dessner, who's a climate scientist in Texas A&M. And at the end of the debate, I turned to him and said, I put the headline of the article up on the screen, and I said, Andy, do you really think I'm a crank and a shill? And he was very surprised. And he said, I didn't even write that. So there's something fishy going on there. Anyway, senior academics talking about scientific subjects should not be calling each other names. And it's very disappointing.
But can you say that for example, that newspapers like the New York Times and the more left-wing newspapers, did they ignore your book, or did they criticize it?
The New York Times ignored it. The Washington Post did run one review, not as a book review, but a columnist talked about the book, Mark Thiessen. That's what the 12 authors talked about in Scientific American was Mark's column. But Wall Street Journal, very positive coverage. Many other right-leaning media thought it was very good. There was just a review in Physics Today by a climate scientist. This is the professional journal of physicists in the US. And he said, if I could paraphrase, you gotta go read it yourself. Koonin's right about a lot of the misrepresentation, but he sells the models short. That I should put more confidence in the models. All right, we can have a discussion about that.
Yeah.
But I remind you of what Palmer and Stevens have said about the models.
So then there are a lot of questions about how do we get the message across? And I mean, your story, I think it's very convincing. It's very well backed up by the IPCC itself. But if people only listen to the media, they will get a totally different picture of the climate change in their mind than you have. So how do we get the message across?
Yeah, let me just elaborate on the problem a little bit first, and before I try to give you an answer if I have one. I talk in non-public forums to a lot of decision makers in companies and in government. And a pretty common reaction is, Steve, I understand and agree with a lot of what you said, but I don't dare say that in public lest I lose my job or the stakeholders, as opposed to shareholders, get me canceled. And they're all walking a kind of tightrope here that is driven by public misinformation. You know, I made my own effort to try to educate, and I'm out and about at a lot of universities and various media platforms. I think I'm having a little bit of an effect, but I think the way it's all going to end is it's all going to come a cropper as the regulations and costs of trying to make this energy transformation become apparent to everybody. People are going to say, you know, why are we doing all this again? And that will be an opening to have a more frank discussion about the climate science.
Like we say in Dutch, that the wall will bounce the ship, or something
very
like
good.
that.
Good.
Okay. Here is a strong one about ESG. Maybe not everybody knows what ESG is, but you probably do. How to deal or break with the ESG. This person even calls it a mafia or omerta ruling. Is it what is ESG, and how tough is it for companies?
So let's talk about ESG. ESG stands for environmental, social, and governance, and is a set of criteria that companies should abide by and get rated on. And if you're a socially conscious investor, then you might look at the ESG ratings to decide where you invest your money. There are a couple of problems with ESG. One is that the measures are not clear and well-defined. And at one point, I think Tesla had a lower ESG rating than Shell or something like that. The second is investing in ESG funds has proven to be not a very good investment strategy. You lose about a point in returns. So if you're interested in making money, it's not a particularly good strategy. And I think the third is the reporting is quite haphazard and burdensome. So a company might have to report all the emissions of its operations and its customers and so on, so-called scope 1, 2, and 3. Nevertheless, it has captured some of the investment community, in part because it's another way for them to make money. There's a rating firm, there are several. One is S&P Global, and another is MSCI, and I forget what MSCI stands for. But you ask, how many different ESG indices does MSCI put out? And the answer is about 50,000, right? So it's big business for them, but it's not a very good investment strategy. There are two books I would recommend. One is called, in this dimension, one is called Sustainable by Terence Keeley. Terence worked at BlackRock and got quite annoyed with the ESG attitude and wrote a very interesting book about alternative ways of investing for impact. Even Larry Fink even wrote a foreword to the book, so it's kind of interesting. The other is a book that's about to come out by Paul Tice, T-I-C-E, and I can't remember what the title is, but it's all about ESG as seen from an inside investment professional perspective. I hope it just all goes away, and I think it will eventually.
Let's hope so. Okay, we do some final questions because it's been a long day for you. He arrived this morning, by the way, at 7 o'clock in Amsterdam. So
it's only what is it? It's about 4 in the afternoon.
Yeah, right? So it's early afternoon for you, so you can go on for. Yeah, right. So I finally found the questions that I selected actually. So. Why would it be in the interest of intergovernmental institutions like governments and the IPCC to convince us that there is a climate crisis and persuade us that to take action against this? So this is what you showed, that this is happening, but this is the motive question again. What is their motive to do this?
You know, boy, it's hard for me to get inside their heads. Control, bigger government, opportunity to reinvent the economy and dislodge vested interests. But of course, if you dislodge, let's say, the big oil companies or the auto companies, you got a different set of vested interests. And there are substantial wind, solar, biofuels lobbies already in the US, and I suspect EU as well. It's hard not to do energy without vested interests because of scale. So that's one. Another is, it's kind of vague, and as I said, it's a good excuse for a lot of things. So it's the gift that keeps on giving. And by the way, the goals that you set will happen long after you're out of office, and nobody will remember.
Yeah. This is an interesting one because I told you this morning in the car that we will have general elections in 2 months, and so they're coming up. And this person asked, what is the best scientific argument to use during the campaign with regard to climate change?
Yeah, you want something that's tangible for people, and I like the economic impact argument that we've prospered over the last 120 years, and that the official projections in the literature are that this is not going to be a big hit overall on the economy. So not a crisis. I think I would love to get on the stage with one of those politicians. I mean, they won't debate me. So I've been doing a series of debates, Oxford-style debates, where you take a vote before, a vote after, and whoever swings the most votes wins. And the people who organize these things have been trying to get certain high-profile scientists to be on the stage with me. They will not do that. It's, I mean, they just won't. And it's very disappointing. Very disappointing.
Several people ask, but this is not your field, of course, but several people ask, how do we reach the younger generation? Today we see as well, you see the kids are like blocking the highway with Extinction Rebellion, some of them. Others go to school. My kids go to school and say, Daddy, nobody cares about the climate in our class. So there are mixed, I get mixed messages from young people, but you have young people at your class.
Yeah, so I can't remember whether I've said this or not, so because I've been in several different conversations today. So I teach 2 courses at NYU. In the fall, now, I teach climate science. And we go through at a deeper level a lot of the science that's in the book. And you're not allowed to talk about the energy system or efforts to reduce emissions, because that's on the response side. And then in the spring, I teach energy. So technology, economics, business regulation, and so on. And you're not allowed to, in that class, question the need to reduce emissions. And you're just supposed to try to understand what it would mean for the energy system to do that. And both classes are taught at the master's level. So these are students who've already been through 4 years. They are a mix of engineers and MBAs, business people. And in both classes, I teach right out of the IPCC and the literature or the IEA reports for energy. And they come away with their eyes opened up. I don't get anybody jumping up and saying, you denier, or, shill for the oil company. They really start to understand that these are nuanced, complicated subjects, and there's no simple answer. So, for 25 students in each class, I'm doing my bit at the level of 50 people a year. There are people who are trying to educate about energy. Scott Tinker at Austin does a wonderful job of films and discussion series, but they show up on public broadcast, and that's not the audience you need to reach. It's the Miley Cyruses of the world that need to weigh in, and I don't know how to do that, frankly.
Yeah. Okay, the last one. This is a very nice last question. Stephen, how do you stay optimistic? Maybe you don't.
We as a species are wonderfully adaptive. We adapted to 1.3 degrees. We've adapted to other major changes in things. Maybe it's the defining human characteristic to be able to adapt. And I have optimism that our kids and their kids will be as nimble and resourceful as ours are. I worry about other things other than the climate. I mean, just to take a different dimension, the US is only 4.5% of population, the globe. We're about 20% of economic activity. That means we're out of whack by about 4 or 5 to 1. And that's unsustainable, okay, as China and India and other major countries grow up. And how do we in the US navigate that situation? I think that's much more important than anything having to do with climate. Europe is in the same boat. I would say somewhat more advanced in thinking about that than the US, but that's what I worry about more than the climate. Mm. But about the climate, I'm optimistic. We will figure it out.
Okay. Thanks a lot.
All right. Good.
Well done. So, thank you for coming. Steve and I will be around for another half an hour maybe before we leave to the hotel. Tomorrow morning we are in Baren. If you want to go there, you can go to the website ourenergytransition.eu. It's a very nice program. Steve is talking about the energy transition there. Theo Wolters, he's here in the room. Theo Wolters will talk about nuclear energy. And there is a German journalist, Alexander Wendt, and he knows everything about the German Energiewende. And he will give a talk about the situation in Germany. So we have a very interesting program tomorrow as well. We keep him busy these days. And there are flyers, Clintel flyers, and at the back, I forgot to mention, you can fill it in for a donation or becoming friend of Clintel, but also for receiving the newsletters. You can also leave your email address and then we will put you on the list for the newsletters. So thanks a lot and have a good trip home and we will be around.